All right, it's a new day. It's time to get started on this. We've got a lot of information to cover still. So in my yesterday or previous videos and stuff, we started into loops. We got several different types, of course, we can do. Some of which are complicated, some of which are easy. Each one is more beneficial depending on what you need it to do for you. After we got into loops, just to recap, so we had the if statement, the else statement, the else if statement, and the switch statement. The while, the for, the do loops. We covered a little bit more on break and continue in our last videos, so we understood those a little bit better, uh, knowing that also they can be used for more than just one thing. So let me readjust my screen here, and we'll get started on where we left off yesterday with the omit array size, because this is where we were, the arrays. I'll try to get through all this in this video, but if I don't, we'll just have to make another video. I try to make it to where my videos only last for no more than an hour. Sometimes they run a little over than that. I know it's kind of hard to keep up with things when they're an hour, but I mean, when you're learning about stuff, there is no rush on learning it. It's more about just understanding it, seeing it, and figuring out how it works. Again, I am not teaching any of this. For example, teaching how C++ works, the code language. I am only just showing you the journey I've taken so far. And through this journey and stuff, I've learned a couple new things or refreshed my mind on some things that I possibly forgotten. Something else I need to do while I'm here is go ahead and add a couple other tabs to this. C++reference.com. These are the sources I'm using, as well as, nope, I don't think it's that one. I think it's this one right here. The learn CPP.com website. And we are currently in W3 Schools, learning about the stuff that they have here. Once we get through all this stuff on the right side of this website, which, by the way, the website and everything is on the right side of the screen, and if you're not familiar with it, the left side of the screen has VS Code, which is a text editor. So let's jump into where we left off from yesterday. So omit array size. In C++, you don't have to specify the size of the array. So it's saying we don't have to specify the size of the array. The compiler is smart enough to determine the size of the array based on the number of inserted values. They kind of have a demonstration of that right here. That whole car thing we were dealing with in one of our previous videos. A string array, cars being the variable name. And this one right here, let's go ahead and put this down here. So this right here is showing, if you can't see it on my screen, I've got the website to where it doesn't really show very good because of the pixel size. By the way, just so you're clear on this, what I'm using this stuff as far as the software and tech is concerned, the software is, Camo Studios. It is free, but the free version is only 720p, which is why you can't see the website very well, especially the smaller print. I'm using that for video. I'm using OBS Studios to make these recordings and to kind of move things around. I do not edit my videos. If I make mistakes, I'm perfectly fine with that. That's how I'm going to learn to improve for future. So Also, if I make mistakes when I say something about C++, if you have a correction on that, please leave it in the comments. If you have a question on it, leave it in the comments. Or if you just simply have a comment on it, leave it in the comments. Um, so yeah, that's pretty much why you can't see some of the stuff on the video, some of the stuff you can. I've enlarged the screen so that the pixel size is fixed a little bit, but still. That's why it's kind of hard to read some of the material on the screen here and stuff, is because the Camo Studios that I use for the recording or for the video, um, and OBS has a 720 pixel resolution over 1040. If it was 1040, you'd be able to see this stuff a little easier. Anyways, what this is showing is standard string, cars being the variable. This is an array, but it's left the size of the array empty, and this array contains uh, 3 different strings. Volvo as a car. Each string needs to be separated by a comma. You need curly brackets. We haven't gotten into the whole curly brackets, no curly brackets. I mean, because you've seen strings before and stuff, and they were never in curly brackets. Well, in this example and stuff, we need the curly brackets later on. I don't know if W3 Schools explains the difference between no curly brackets, and parentheses. We'll get into that later, though. I found that material somewhere else that I thought was very interesting. So for now, let's go ahead and keep doing this. Yeah, that's lowercase. It needs to be kind of uppercase, but it's fine either way. You know what I'm referring to when I say it. Forward. And then that's the end of that. So there. I got a little comment after that too, but most of the time when we have been using arrays, we are specifying the amount of elements in the array through the variable name with these square brackets. In this case, we are not. This is specifically saying that the compiler is smart enough to determine the size of the array based on the number of inserted values. But when you go to put this into your code and stuff, it may have something there showing that that's not filled in, and that's perfectly fine. It should still compile, but it may not, just depending on multiple things: the program you're using, the software you're using, the computer you have, etc., etc. So, or the compiler you're using at that even. So there's how it kind of looks. They got an example for us right here, which is the next thing and stuff. We're going to go and write this code into here. So let me clear out this old code here. I could have went ahead and used that, but the exercise is good for me. So rewriting code is kind of the same thing as getting fit and stuff. You wouldn't say you went out for a run and your body doesn't experience it. You would do it anyways just to get the full benefit of it. So we got another string right here. Cars is a variable. Square brackets. I don't know why it went that far. That curly brackets. Now, if you notice and stuff, cars had the error underneath it at first until I put the curly brackets up. So the program is kind of giving you hints onto what is missing, but then when you start filling it in and stuff, sometimes that disappears. And sometimes you have to give it a couple seconds for it to fully register what you're doing there. So the same thing we have in the comments down below is what we're putting up here for the code. And then we're going to end that right there. Oops. All right. So yes, in this case and stuff, we don't have anything filled in. Before we had something filled in for the array size. This time we do not. If you do have something filled in for the array size, say we have 2 right here. Well, we don't have 2, we have 3. So when you put 2 in there, it's like, why do you have a third one when we only have 2 in there? So yeah, that can kind of be helpful because you can kind of fill it in first and then put the number in there later, or you can just leave it alone and stuff, and the compiler will figure it out for itself. Kind of like the keyword auto we were using before, letting the compiler figure out what the type was going to be on its own. Okay, so we got some more information here. However, the last approach is considered as good practice because uh, it will reduce the chance of errors in your program. So yes, having it filled in reduces the chance of errors. I would definitely go ahead and put the elements in first, and then put the amount that you have as far as elements are concerned second. If you put it in there first and then you fill it in and you end up subtracting or adding one later on, then your count is wrong. So I guess you can just, it's not that hard. You can simply just adjust as you go along there. So basically this is just saying you don't have to have it in there. Now, omitting elements on declaration, it is also possible to declare an array without specifying the elements on a declaration, which this is a declaration in this case because we've declared uh, the type as being strings with the variable name, and that it's an array with the square brackets. In this case, though, we have given it values, so it's a full declaration. It's not a partial declaration. It has everything there. But in this next example right here and stuff, we don't necessarily have everything. So if we get rid of this right here, we kind of get that right there, but that's because we don't have this. So we just add that right there, and that will remove our error from right here. This right here is still kind of got an error because we have the variable name, but we just don't have any values for it. And again, it's empty, which in a way is a good thing, in a way is a bad thing. Now, if you remember right, when we wanted to add or replace something, we would simply go to the next line and give our variable name the spot we wanted to be in with square brackets, and then uh, whatever we wanted in that place. For example, Volvo. This is kind of based off this second example right here and stuff. We got two different things going on though here. So mouse overing that, or putting the cursor on top, incomplete type string. You can't have the square brackets in there because we have nothing filled in for it. But in this case and stuff, we have the square brackets right here, but we're not telling anything about where this is supposed to go. So we do need to add something right there. So once we do that right there, this is still kind of an error right here because it doesn't have a number. So at this point in time, we just filled it in with the number. But if we keep going and add another one, cars, position 1 is BMW in that. Now we have a second one here, but it doesn't match our array. And we're not getting the errors currently. So we're adding another one, but this right here is probably going to produce an error since there's only one. So if it doesn't produce an error, then it's not going to read the BMW. It's only going to read the Volvo. Let's go ahead and save that and see what happens. We're just kind of playing around with the code to see what happens here. So in this case, nothing happened. Probably because we don't have an output. So let's go ahead and add that in there. Standard output. Oops. Cars. Save it. Run it again. And we still don't have any kind of output yet. Why don't we have an output of cars? It's not even giving us an error. I'm trying to determine if there's something else going on here. Let's go ahead and put in uh, 0. So this is me kind of refreshing my mind or relearning this stuff again. It's not printing up anything yet still. Let's see if we get rid of that. See what it does then. I don't think it's going to do anything still. No. Okay, so as of right now, I kind of at a loss on this, on how to print this out, or on this example. I mean, the example is showing that we can have two in here right now, and position 1 and position 2 are filled in for us. Maybe we need to add a few more things. So this is where I'm going to either be refreshing my mind still or learning. Spell string right first though. Save, run. Okay. So in this sense, we did get a printout finally. Let me clear this up so it's easier to see. We got BMW because it's asking for position 1, not position 0. If we left this blank, how would this react? So we do need to have the string name in there, and it's giving us a problem right here. Let's see if we can clear that out and see if we can get the entire string. No, we cannot. So you have to have, for this to print out, something in there. So I am pretty much standard string. I want the entire string of cars at whatever position is what this is going at. Volvo, whatnot. So yeah, so we can kind of do this right here. Let's keep reading through here. I know I'm a little confused on this, and it may be a little bit confusing to some other people as well and stuff, but the idea here, the concept of this is the fact that if you want to declare it right here, you can. We got two in there right now, and we got two down here. We got each one for each position. If you change the position and stuff to 1 and 2 and leave 0 empty, I'm not sure what that would do either. Um, But the idea is that you don't have to have them in a line right here. You can simply come down this way instead of going across the screen to where you may have 15 in there and stuff, but instead of putting 15 across the screen, you're putting 15 down right here. That makes it a little, maybe a little bit easier to read the code and know that there's 15 there total, sort of thing. They don't have a whole lot here because I can imagine trying to put 15 different strings in there and it running clear across the screen for 15 different elements in the array, where putting 15 elements going down the page would be much easier to read, in my opinion. That you would also know exactly where each one is in this case. Number 7 is this one. Number 10 is this one right here. Instead of having 1, 2, 3, 4 sort of thing. I can kind of give you an example of this. So if we kept going with this, put the curly brackets in there. Volvo, I think that's kind of what this is getting at. Chevy, I'm just making up whatever I can think of right now. Honda, Mazda, Ford, Dodge, Fiat, Nissan. So now we've gotten literally what is that? So instead of counting all these, I mean, you see I'm already having to count to see how many there is in here and stuff just to put a number in there. So Why make it harder on yourself to do that when you can keep track of each one, know exactly how many there are, and know the exact position of each one just simply by getting rid of this right here, declaring that, and then coming down here and continue adding cars. This may be a little bit more work and stuff, but at least you ain't got to count them all up every time. So it's optional. Just giving you another way of doing this. Um, in fact, something else you can do is simply copy, paste, 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 paste for however many you plan on having total. Um, and then replacing this 3, 4, 5, 6, 7, 8, and then changing the names of them. So we're gonna put Chevy in here. We're gonna put Nissan here. We're gonna put Dodge, Honda, so forth and so on. And now you know exactly which position. You know there's a grand total of 8, so we can adjust this right here to 8. And then we also know exactly which position which one is in. And it makes it a lot easier to read this than when it does a long string and having to count which one's which. Sort of example. You know exactly which position which one's in. Especially if you get into much deeper and stuff over 10, 15, 20, you get to 100 different ones. Yeah, you may have to scroll up and down the screen to find the specific one. But you can also do this as well. Oops. I think you would need, nope, you would have to actually have that in there. And you space it out like that. Sort of thing. So, there's a number of different ways you can do this. As you can see, I'm kind of playing around right here and getting, there's 9 different ones right there. Each one's marked. So it's actually not 8, it's 9, sorry. I'll readjust that number. Save it, and now the code's a little more condensed. It might be a little bit harder to read and stuff. It might be actually a little bit easier if you put a little more space in between there, because the compiler's going to ignore the space. And then make sure that they were all, let's go ahead and move that one forward. There we go, like that. That may be a little easier to read. You can put more space in there if you want to make it easier. There. Now you got all 9 of them in there. They're not going down the screen as far. If you want to go farther over, you can, sort of thing. Add more to it. This right here would probably make a lot of sense. There may be another way of doing it besides this way that other people know about, but yeah. Even when I downsize the screen and stuff, you can pretty much see all of them, all but the last 3 over here, but still. So it's just another way of kind of doing that. We need to get rid of that one right there. Moving on, note the example above only works when you have specified the size of the array. So this only works when you specify the size of the array. If you leave this empty right here, then you can have a long list of 25, 30, 40, whatever, 100, whatever. But they all have to be in the curly brackets. In this case right here, you have to give it a specific number for doing this right here before you do it. Or after you get done doing it and figure out how many elements you have in the array. If you do not specify the array size, an error will occur. So if you leave that blank right there and you go to print whatever position it is, 8, and you leave that blank, you're going to end up with a compiler error, is what it's basically saying. Okay, fixed size array versus dynamic size vectors. Okay, now we're going to introduce vectors, and we haven't even discussed that, so we have no idea on what a vector is. Not to mention dynamic. It was way in the resources and stuff before I figured out what dynamic actually was. or even vectors, because it doesn't give a very good definition of what vectors is. And I'm still not, I mean, I've done vectors before, but I'm going to have to do it a couple more times in order to sink it into memory. But you will often hear the term fixed size or dynamic size when discussing arrays in C++. Okay, so hopefully it's going to explain this really good in detail. This is because the size of an array in C++ is fixed, meaning you cannot add or remove elements after it is created. So once it's created, you cannot add or remove. Now, that doesn't really make sense because we were doing that before. We were switching out an element in it before just by typing one of these in again and stuff, and keeping that same right there and adding in a new element to replace the old one. So that does not make a lot of sense. But at the same time, it is saying fixed. So we don't know what fixed is, we don't know what dynamic is, and we don't know what vector is. Three new words that we're using here that we have no idea, and it may not even tell us what this is. It's just giving us an example of a fixed sized array. Array's fixed size example, which is pretty much declaring this right here, which it is fixed because you can't add or subtract without adjusting that number right there. Or if you had it running across the screen, you could probably add more whatever, then you could leave that empty. But in this case, we can't. The example also states that trying to add another element, a fourth element, to the example that they're currently doing right here would cause a compiler error, but they're not really adding another one, they're replacing one according to this. So let me go ahead and write this example in here real quick, because a lot of what they're saying just doesn't make sense for what we've done in the past. So first we got a comment here, an array with 3 elements, and then the array itself, again we're using this right here, we're going to declare it 3, that's what the example has there, is curly brackets. So we got so this must be the fixed. If you have something in there, that must mean it's a fixed array. It's the best I'm gathering right here from this. Volvo. If you don't have anything in there, then that must mean it's maybe dynamic. I can only guess since they're not declaring what those words really mean. They're just giving an example instead. BMW, and then Ford. And then that'd be the end of it right there. Now, according to their thing right here, and they got another comment right here, trying to add another, give me just a second. All right, I am back. Had a little bit of a distraction there, so I had to pause the video, and now I gotta remember where I am. So yes, they've introduced fixed, dynamic, and vectors. And it doesn't look like they're going to explain them too well because the message below it, or the text below it, just says you will often hear the terms fixed size and dynamic size when discussing arrays in C++. This is because the size of the array in a C++ is fixed, meaning you cannot add or remove elements from it. And they give an example of something where it's going to error out because of an issue. I was writing that into here. So try to add another element. In other words, a fourth element to the cars array will result in an error. Okay, so that's the comment they have here, and then the example that they're going to use is cars position 3 will end up being Tesla. And in this right here, no, we don't have a position 3. We only have position 0, 1, and 2. We do have 3 elements in there, but this wouldn't be anything different than what we've already seen where we're putting a 4th one in there and stuff, but we only have 3 declared, so it kind of gives us an error that this one right here, or what calls an error, so forth and so on. But yes, I believe you still should be able to change it. But I guess what they're saying is this is what is known as a fixed array. Not having that in there, this is maybe known as a dynamic array or dynamic size, fixed size and dynamic size. So, and in this case, if you didn't have anything in there, then yes, this probably would work. In fact, we can try that out right here. Standard outcome or output. Yeah, say it properly first. Standard string. And again, I may not be putting all this code in here properly. It's been a while since I've done this. Cars, position. This would be position 3 because we've added a 4th one in there. So position 3 and end, save, run code, and yes, Tesla gets added to it. So again, maybe if you have a number in there, maybe that's what's considered a fixed. It just tells us we're going to hear about fixed and dynamic size. It doesn't tell us what they are, or vectors at that point. Maybe later on it will and stuff, but yes. So with a dynamic, I'm not even going to say that word dynamic because we don't know what it is, or fixed, or vectors. I'm going to leave that out because I have no idea what that is, since they're not really saying what this is. Actually, it is right here. Arrays fixed size example. So with the number in there, indication of how many elements are in the array, that's what's known as a fixed size. But if this is a dynamic right here, when you have it empty, and you can add more to it or whatnot later on, that might be dynamic, but like I said, I'm not going to say it because I don't know exactly. So we'll wait until I don't know why I'm still yawning so much. Sorry. Anyways, moving on. We do have the word vectors right here in this. So let's see what this says. For operations that require adding or removing an array element, C++ provides vectors which are resizable arrays. So maybe this is known as a vector. I have no idea. The size of a vector is dynamic, meaning it can grow and shrink as needed. Vectors are found in the vector library, and they come with many useful functions to add, remove, and modify elements. Okay, so in my opinion, from what that just stated and stuff, I was sitting there thinking, okay, so I still don't really get, since they're not really explaining it very well, the difference between, and this is a struggle I was consistently having with this for W3 schools. Um, since C++ is a very complicated language compared to HTML, CSS, and maybe even Python, I don't know. I was really struggling with trying to understand this and learn this stuff when I was going through here, and it's still not really making a whole lot of sense. Um, so if this is an array right here, whether it's fixed or dynamic, if there is even a such thing, um, then what is a vector? And I do have an example of a vector dynamic size. That's making me think that maybe dynamic size are vectors only, and fixed size are arrays only. But I'm pretty sure that's not true. I don't know yet. But it's given us another example, so we're going to change a thing around here. We're going to take this out and change this to vector, because that's the comment that they have here, and then we're going to adjust this right here to where this actually says, because this is the example vector, uh, with parentheses. Cars, they do not actually have square brackets in there anymore. Everything else is the same, but this won't work because of the fact that we're not using the vector library. So if you want the vector to work, you have to include vector, and then this should disappear. And it didn't. Maybe, so there's one other thing we can do right here. Okay, so that kind of fixed that, kind of. String. Yeah, so we're just simply getting errors right here. Um, the rest of this example, we're going to get rid of this right here. Actually, we're going to get rid of all this right here, go and write the rest of this example in here, and then look at what they have on the next, on the try it yourself screen to see what is different from the code. Element to the vector. We're also going to get rid of our output too. We don't need the output in here right now. We're just trying to understand this. We're not trying to understand how to. So adding another element to a vector when you've barely explained what a vector is. Cars dot push, and here's another keyword that they're using. Pushback. What is that? Tesla. At this point in time, I was pretty much ready to give up on W3 Schools for Learning C++, because there's a lot of phrases just right here alone that would be confusing to anybody, in my opinion. We look at their code, so they are including vector, vector string cars. So I have it in, oh, that's where I messed up. So it's not parentheses, it's angle brackets right here. That may be the difference. I'm pretty sure that was an example. I just missing that. I just didn't see right. Yeah, they got the curly. So that fixes all that except for the string right here. I'm still okay. So here's the other thing missing. Standard. That's why that's there. That fixes that entire line right there. Because you can't have strings by itself, but they're using the. Okay, so now I think the code is actually all correct. I had the parentheses in there, which, I mean, if it told us that vectors, when dealing with vectors, this and that and that and this kind of explained it and stuff, I may not have missed it, but like I said, at this point in time, I was ready to find another source to learn C++. Especially when I see this right here and I'm like, okay, so what's this, what's that, what's this? So then I come to AI and ask the question, what's this? What's that? What's this? And now I'm actually not using W3 Schools anymore to educate me on C++, but I'm actually using AI to understand the education. So that's a redundancy right there. Using AI to educate yourself on an education website about C++. That's like having a teacher in your classroom and stuff that's telling you this stuff, but then you have a teacher standing right next to you explain to you what the teacher that's teaching this stuff is saying to you. So let's keep moving on and stuff. We got this figured out right here. I was using the wrong brackets right here. It was supposed to be the angle brackets, not the curly brackets, or not the parenthesis brackets. We still have no idea what this right here even means because it hasn't discussed that at all. I mean, the only parts that we understand, it's just mainly this part right here we don't understand because it hasn't given us any indication what that even means. But here in yellow, this is just an introduction to vectors, brief introduction. It's not even really an introduction. I would just say it's really just showing you vectors. without explaining anything at all, to let you know that resizable arrays exist. Um, since since I don't support the website, and I may not unless they make some changes to fix this. I don't have the money to right now anyway, so I wouldn't be able to. I can't complain about the website, and I'm not really going to. I'm just stating that if you're going to use W3 Schools, yes, it's again just showing you it exists. Because right now there's a lot of other stuff for C++ that we don't even know exists. So we have discovered that there is such thing as a fixed size, a dynamic size. We don't know how these work with either one of these arrays or vectors very well yet. And then we know that there is a such thing as vectors. So we are discovering it. We are not necessarily learning about it. You can't really learn about it until you get farther into it. So anyways, in the yellow here, was just an introduction to vectors to let you know that resizable arrays exist. You don't worry if you don't understand the syntax above. You will learn more about vectors and other data structures in later chapters. And that's nice to know. Probably would have put this up above here, like below vectors, instead of below the example. That way you know when you go to the example and stuff, you're not sitting there confused, not moving past it. But that's just me. Anyways, we got the code figured out. We got it written here. That's all we need right now. We got an exercise right here we can do, but we're not going to do the exercise. We're going to move on to the next thing. C++ array size. Get the size of an array. I thought we already did this once, maybe not. Get the size of an array. To get the size of an array, you can use the size of operator. So now we're going to introduce something else, size of, which I don't think we've done yet. And let's go ahead and get rid of this right here. Get rid of all this code. And they got an example right here. So int my numbers as an array. 5 is the count of the array, is curly brackets 10 comma 20 comma 30 40 and 50 in the statement, and then they're going to output size of, and this is how you would see size of. Didn't explain it, but this is how you would see it. So you are now learning that the keyword or term size of exists in C++. So you save that, you run the code to see what this kind of does. 20, and we have no idea what this 20 even means. I do from seeing all this, but most likely you're not because you have no idea what size of does. So, but it does show you the result should be 20. That was helpful. Moving on, why did the result show 20 instead of 5? So we were expecting 5 because there's 5 elements. That's not what size of does. Don't get that confused. So if you don't understand what size of does, just know that it exists right now. That's all there is to this right here. It exists. Don't try to understand it yet. Keep moving forward. If you get stuck on something, you're gonna end up spinning your wheels to try to figure this out. Yes, you can Google it. Yes, you can AI it. Keep moving forward through this stuff. Discover everything there is first, then start trying to understand it. It's all going to come together eventually, but there's a lot to discover in C++. Anyways, why did the result show 20 instead of 5 when the array contains 5 elements? It's because size of operator returns a size of type in bytes. So, we haven't gotten into this at all. But the size of any single integer, okay, for example, I hit the wrong key by mistake, sorry. For this example, int x is 5. Okay. Any integer type is 4 bytes. You're discovering this. So this type right here is 4 bytes. In this case right here, we have 5 different values and variables. Even though this is only one variable, there's still 5 values in this. So this is considered 5 different integer types being declared. So the size of numbers would be 5 times the size of integer. And I know that's very difficult to understand. Let me see here. So integer will always equal 4 bytes, not bits. Keep that in mind because there is a difference, not bits. And we'll discuss bits and bytes later on, but they're throwing a bunch of things at you just so you have it discovered. So the array above my numbers, the array my num contains 5 elements, or 5 different or 5 different integers. So since each integer is 4 bytes, and we have 5 integers in total, the math would look like this. 4 bytes times 5 integers, which comes to be 20, and that's why it printed 20. So that explains, so we can keep moving forward. You will learn from the data type chapter, which is, you learn from the data type chapter that an integer type is usually 4 bytes. So from the example above, 4 times 5 is 20. Let's take a look at that. That may have been the case. Yes, this is the brief area where it told us. And actually it said that an integer can be either 2 or 4 bytes. But in this case, it was not having us look at this right here so much. So it's kind of like just a little bitty spot on your education, because we were morely concerned with what an integer did at the time when we were looking at this in the video. An integer stores whole numbers without decimals. We were just learning about integers. We weren't learning about the bytes. But yes, this little bitty spot right here was included on it, so they can say this for this section right here. Actually, I think it's this right here. For this section right here. So again, you know it exists. That's the whole primary thing behind this. Learning more about it and stuff, because there's so much more to learn about the types, the sizes, that sort of stuff, especially when you're dealing with other things that we have not even discovered yet. So let's keep moving forward. To find out how many elements an array has, you have to divide the size of the array by the size of the first element in the array. Let me say that one more time. To find out how many elements an array has, you have to divide the size, which in this case, let me run this again. Just let me save it real quick. Save. run. So you would have to divide the size of the array, which this is the size of right here as we printed out, the size of by the size of the first element in the array. Okay, so size of again. I wouldn't even see you have to divide it by the size of the first element in the array. Uh, because here's the thing. In that example, it shows data types right here. This is saying that it can either be 2 or 4. So how are we going to know which one it is? Is it 2 or 4? If we divide this by 2, that means there's 10 elements in there. If we divide it by 4, that means there's 5 elements in there. Again, we know it exists. I would probably ignore that entire line right there until we learn more about size of and the size of each types. I would ignore that in sentence right there. Moving on, the example right here. So, and that's kind of showing you how to do the math of this and stuff and write it in the program. So we're going to get rid of this code right here. We still have this. We're going to go and keep this right here, but we're going to add another line right here. Integer get array length is size of my numbers divided by size of my numbers. But it's not just my numbers, it's my numbers and whatever's in the first position, 0. So it's the array divided by the array's first element. So in this case right here, this would work. If you were doing it in your head and stuff, you'd be confused because you don't know if the values are 2 or 4 based on the information it gave you about data types in previous chapters. So we're using the code right here to get that exact thing right there. So we're going to also change the output because I do have an output here, but the output's not size of my numbers anymore. It's actually the variable name for the second integer. So we're going to change size of my numbers to get array length. Oops. No, I didn't finish this up. End that. So now we got our example built. We got it saved. There we go. Run the code. They expect it to print out 5, and yes, that's what it prints out is 5. Before we got 20 for the size of all this right here, so that means that each element or each value is 4 bytes, since there's 5 different ones in there. Again, kind of complicated. You're learning this for the first time. You're discovering it. My biggest issue in this was, how am I going to memorize all this stuff when I'm only just discovering it and I'm not learning about what this does or what this is? Well, I could tell you right now, C++ is a huge library of stuff, and I still have not fully covered the basics myself. Even with 2 months of reading this stuff and spending hours. I mean, when I was doing this, I was probably spending 8 to 10 hours plus a day reading through the material, doing the exercises, doing the examples, and I've still not got all of the basics covered yet. So, there's a lot. Moving on. That's why I keep saying moving on and going through this. Loop through an array with size of. So how do we loop through an array with size of? In the array and loops chapter, we wrote the size of an array in loop condition. I is less than 5 was the expression we use. If you remember any of the loops. It's not specifying any which loop and stuff, but any of the loops. We eventually use something like this to loop through a bunch of things because there was quite a few of them. This is not ideal since it will only work for arrays of a specified size. So if you don't have a specified size to where you can adjust the size later on, it may not work, is what I'm gathering from this. I think this is the last part we're going to discuss right here. We'll make another video moving on to the rest of it. However, by using the size of approach from the example above, which is referring to the example we have right here, by using the size of approach from the example above, we can now make loops that work for arrays of any size, which is more sustainable. You would have to be very creative and wildly use your imagination in order to know how to write a code that would loop through this, especially if you're new, to get the size of each value or to print each value. If you are like me and you are just still learning about C++, you probably won't know how to write the code for this. So still going through the examples is very helpful. So they got the first one right here. This, I'm going to type this into here because this is actually not the example. This is saying instead of writing something like this, oops, int my number, square brackets, 5 is curly brackets and then all the elements 10, 20, 30, 40, 50, and 4. And so this would be the for loop. Int I is 0, I is less than, well, I is less than 5, because there's the statement. So these are the statements. This is not the condition. If you remember correctly, for a for loop, it's statements, not conditions. And then and then the code to run square brackets I. Okay, so it's simply stating instead of writing the code like this right here to loop through the array, or what was the purpose of doing this approach? I'm still yawning. I don't know why. Maybe because I'm talking so much. Who knows? I don't know. Don't really care. I'm only worried about discovering all this stuff and understanding what we're doing here. Instead of writing this right here to loop through the array with size of, because we don't even have size of in there. It is better to write this. So here's the new example of what to write. So we're going to keep this one right here because we're going to still use this. We're going to adjust this to 4 parentheses. Going to remove everything up to the size of right here. We're going to add in int I is 0. Then that I is less than space size of numbers divided by this right here. Then once that ends, then we're going to increment I and then we need to finish it off with our parentheses and no, not in that. And go to the next line and put our curly brackets in place, enter. And then we're going to take this output right here. We're going to move this output up to here into the curly brackets, but then we're going to change this to my numbers, square brackets I from the for loop, um, and then a new line each time it prints. So this is literally looping through to get the size of, I think, each element. So we should have five times, if I'm not mistaken, I think. Let's see what this does. 10. No, it's using size of to determine what each value is in the array. Kind of complicated code, especially since you probably still don't fully understand size of number. And since we've only dealt with the for loop a few times, and we've only even seen this right here entire line of code just once. Come on, cursor. There. We've only ever seen that once. We've seen the division part, but it's the size of one thing divided by the size of another thing, and we don't fully understand size of yet, so this is probably still even complicated as it is. So, but we wrote the code, we discovered it. That's the important key right there. Moving on to the next thing, because we need to keep discovering every aspect of C++. And we got a lot of material to discover before we can start diving deeper into each thing that we discovered to understand how it works. Okay, so note that in C++ version 11, you can also use the for each loop, which is even cleaner and simpler. It is. So we're going to keep all this the same. What we're going to do is we're going to actually take this right here and remove half of this line right here. Actually, majority of this line right here. And we're going to put num colon my nums. And then change this right here to nums. Or num. Then save it. Granted, yes, that's a lot simpler to write, but it still may be kind of confusing since we've only discovered a lot of this stuff. So we're still just kind of, our mind is like probably crashing and overloading and stuff because of all this new information being thrown at us so quickly. So we've already saved it. We'll go ahead and run it. We should get the same response. Yes. Okay. Moving on. It's good to know. That's the key. Good to know about it. The different ways to loop through an array, since you may encounter them all in different programs. When we move on to the next part of this chapter right here, 5-10 minutes into that chapter, you're probably, especially if you're new to this or even at my level, you're probably going to forget about this right off the bat. But we know it exists. We just got to keep running through it and running through it and running through it, reading the material on it when we get to that part of the journey. Again, I think I was going to go ahead and end this video at this point in time. It's a lot of information right there to absorb. The size of idea, the uh, using size of to loop through an array. We've barely gotten into arrays and stuff or fully understand how arrays work. We had the whole fixed size array and then the dynamic size and vectors. So there's a lot. So that I still keep going. I don't know why. Anyways, yeah, go ahead and count how many times I yawn and stuff, and throw that into the comments on how many times I yawn. I don't know why I keep yawning so many times. I think it's yawning actually doesn't indicate tired as far as what I remember. It actually indicates lack of oxygen. So maybe it's the fact that I'm talking so much and not breathing while I'm talking, causing that problem. Anyways, Um, so yeah, that's that for now. When we come back with our next video and stuff, we'll work on the C++ arrays real life examples, and we'll go from there. This video is already running to an hour plus long, just going through that much of it because that was a lot of information to discover for the first time, especially with C++. That's kind of how my journey went, and I was getting lost more and more and more and more. And I was like, okay, where's this at? Where's this at? And going through this a second time and stuff, I'm realizing it's not so much about learning them in W3 schools as much as it is about discovering all this stuff because there's a lot of information here. And believe me, the 28 chapters in Learn CPP kind of reflects on how much that is. Not to mention, even once you go through all that and stuff, you're still not gonna. I mean, you'll have the basics down as far as knowing about them. If you have them memorized, it's a different story. Especially since I don't even think that goes through libraries. I think the Learn CPP just pretty much goes through this beginning part and stuff, and then you gotta learn about libraries and stuff, and it doesn't even cover everything in here. I'm pretty sure, but still, there's a lot of work here. Um, I don't think this is something you're gonna learn on a weekend at all. I don't think it's something you're gonna learn in a month. It'll probably take you 6 months to a year to learn. But yet there are people out there that have been doing this for years, and they are still learning. This is something that you're never going to stop learning about. So if I know there's some things out there that say is coding or is C++ or is this or is that dead, and I'm going to say flat out no. With millions of variations in this and stuff, there's just no way. Just like food and stuff, I'm pretty sure you probably have not tried all the food in the world, even though you eat 3 meals a day and you've probably been eating every day and so many meals and stuff. And there's probably still a meal out there or food out there and stuff you've never tried before. A color you've never experienced, some new experiences you've never tried or discovered. Yes. So that's kind of the whole fun part about learning. Um, there's always something new to learn. So. But I think that'll be the end of this. When I pick up next time, we'll start right here. But until then, like I said, if I said anything wrong, um, if you have any questions or comments, leave them in the comments. Correct anything I said wrong and stuff in the comments if you want. That's fine by me. This is my journey. This is not me educating you on how to do this. I'm just kind of giving you an idea, inspiring maybe, hopefully. Yeah. Till next video.